A washing machine built in 1975 lasted an average of 19 years. The one you bought last year will be lucky to see 10. But here's the part that nobody tells you at the point of sale. The component that kills it costs $5, and the manufacturer made absolutely certain you can never replace it yourself. What most consumers never realize is that this is not a quality control problem. It is not a supply chain problem. It is not inflation or overseas manufacturing or any of the explanations the industry prefers. It is one specific design decision made deliberately that converted the most common mechanical failure in a washing machine, bearing failure, from a $50 repair into a reason to buy a new machine. And once you understand exactly what that decision is, you will never look at a washing machine the same way again. Walk into any appliance repair shop today and ask the technician what they see most often. Bearing failure. That is the answer, almost universally. The drum wobbles. A grinding noise develops during spin. Eventually, the machine sounds like a truck transmission failing at highway speed. The homeowner calls a technician. The technician opens the machine, and within minutes, the diagnosis is the same. Worn drum bearings, a textbook mechanical failure. Predictable, understood, and in a previous era, completely affordable to fix. The Norwegian University of Science and Technology tracked appliance lifespans across decades of ownership data. Their 2025 study, published in the Journal of Industrial Ecology, documented what repair technicians had already been seeing for years. Median lifespan for washing machines dropped from 19.2 years to 10.6 years, a 45% collapse. And that inflection point sits precisely between 1992 and 1998. Consumer Reports puts it more simply. Approximately 20% of washing machines break or stop working within 10 years of purchase. That is not a defect rate, that is a product category. To understand how we got here, you need to understand what came before. Through the 1990s, washing machines were built around a split tub design. The outer tub came in two halves, bolted together around the circumference with 15 to 20 fasteners and a rubber gasket seal. Inside the rear half sat a machined metal bearing housing, cast aluminum or die-cast, with standard deep groove ball bearings pressed into precisely machined seats. A shaft seal kept water out. That was the entire bearing system. Straightforward, accessible, and built from components that any industrial supplier in the world could provide. When those bearings wore out, a technician unbolted the tub halves, pressed out the failed bearings, pressed in new ones, replaced the seal, and reassembled the machine. Total parts cost $20 to $50. Total repair bill, including labor, rarely more than $250. Maytag ran their Lonely Repairman advertising campaign from 1967 through the following decades, premised on the idea that their machines simply did not break. The repairman had nothing to do. That was the joke. And for a long time, the engineering behind the joke was real. Repair technicians still report servicing Whirlpool machines from the Reagan administration, still running, still fixable. The bearings those machines used were, and still are, standard ISO industrial components from the 6000 series. A 6205 bearing had 25 millimeters inner diameter and 52 millimeters outer diameter. A 6206 bearing had 30 millimeters inner diameter. These components are manufactured by SKF, NSK, NTN, and FAG, and dozens of suppliers worldwide. You can buy one today for $5 to $15. Every industrial bearing catalog on Earth carries them. Nothing about this component became obsolete. Nothing became unavailable. The bearing did not change. What changed was whether you could access it. This is where the real problem begins. Starting in the late 1990s and accelerating through the 2000s, manufacturers began replacing bolted split tubs with permanently sealed assemblies. The technique is called ultrasonic welding. High-frequency vibration fuses two plastic surfaces together at the molecular level, creating a bond stronger than mechanical fasteners and completely permanent. No seam, no access, no disassembly path. Look inside a modern washing machine tub assembly, not the inner drum, which you can see. Look at the outer tub. On a Whirlpool Duet model, WED7590FW, on a Samsung front-loader model, WF45R6100AW, and on most LG model WM3700HWA, built after 2005, the outer tub is a single plastic unit. The bearing housing is not a separate component mounted inside it. It is injection molded into the tub itself during manufacture, fused to the rear wall in a single plastic casting. Samsung's own patent, filed in 2010, describes exactly this process. LG's sealed rear wall patent was filed in 2003. The manufacturers documented the transition themselves. The bearing is physically entombed inside a component that was never designed to be opened. When that bearing fails, and it will, because bearings in high-speed machinery always eventually wear, the manufacturer's prescribed repair is replacement of the entire rear tub assembly. On a Whirlpool Duet, the rear tub half costs approximately $430. The spin basket costs another $485. Parts alone exceed $900 before a technician touches the machine. Samsung quoted one owner $500 for the tub assembly, plus $120 for diagnosis, plus labor. $715 total for a machine worth $900 new. The technician's threshold for recommending replacement over repair sits at 50% of replacement value. Bearing failure in a sealed tub machine crosses that threshold almost automatically. The $5 bearing triggers a $700 decision. That is not an accident, that is the product. The evidence from the repair industry is consistent and overwhelming. A peer-reviewed analysis of over 11,000 repair diagnoses found that bearing and shock absorber failures account for nearly 14% of all washing machine failures, but only 24% of those failures are actually repaired. 76% go unrepaired. The study noted the pattern explicitly. Unrepaired bearing failures are observed mainly in machines with plastic tubs where bearings are sealed to the tub. The bearing did not become less fixable. The machine was designed so that fixing it stopped making economic sense. The efficiency mandates compounded the problem. Department of Energy standards tightened 6 times after 1988, each revision pushing manufacturers toward higher S-bin extraction to reduce remaining moisture content. Before the 1990s, machines spun at 600 to 800 revolutions per minute. Modern front loaders operate at 1,200 to 1,400 revolutions per minute as standard. Centrifugal force scales with the square of angular velocity. At 1,400 revolutions per minute, bearing loads are roughly triple what they were at 800 revolutions per minute. But the bearings did not get larger. The housings did not get heavier. United Kingdom appliance engineers confirmed the structural mismatch plainly. As washing machines get faster, their quality does not increase to accommodate the extra strain. The motor is the same size, the suspension is the same, the bearings are the same. The German Environment Agency tracked the consequences. The proportion of large appliances replaced within 5 years due to defect rose from 3.5% in 2004 to 8.3% in 2013. That nearly doubled. In the same period, average first-use duration for washers fell. These are not coincidental trends. They are the measurable outcomes of machines built to spin faster inside components designed for lower loads. Meanwhile, the environmental cost continues mounting. In the European Union alone, premature appliance replacement generates over 2.5 million tons of electronic waste each year. For the average homeowner, the financial reality of this plays out over 20 years in a way that most people never calculate at the time of purchase. 3 budget machines at $550 each, replaced at roughly 7-year intervals, cost $1,650 in purchase price alone. But washing machine water damage claims average $7,000 to $12,000 per incident. State Farm paid nearly $30 million on washing machine claims in a single year. Budget machines carry cheaper hose connections, lower tolerance fittings, and more plastic at every water-bearing junction. One failure event eliminates every dollar saved on the purchase price, and then some. When calculating total cost of ownership over 2 decades, the initial price premium for a repairable machine becomes negligible compared to replacement cycles. The machines that carry the highest risk share the same profile: front-loading design, plastic outer tub, sealed bearing assembly, direct drive motor with no belt to absorb vibration, digital control board located above the steam line. Samsung, LG, Whirlpool, GE, Frigidaire, in their standard consumer product lines, all fit this description in varying degrees. That combination is not inherently defective, but it concentrates failure risk in components that either cannot be repaired economically or carry replacement costs that approach the machine's full value. What still works, and why, comes down to design principles rather than brand loyalty. Speed Queen builds residential machines on the same platform as their commercial laundry equipment. The TC5 top loader uses a steel gear-driven transmission, commercial-grade bearings, and a stainless steel tub, and it weighs nearly 200 pounds, roughly 30 pounds heavier than comparably sized competitors. The machine is tested to 10,400 cycles, equivalent to 25 years of normal use. The 5-year full parts and labor warranty is 5 to 7 times the industry standard. Yale Appliance tracks service rates across thousands of real transactions. Speed Queen runs at 3 to 4.5% annually. Most competitors run significantly higher. Miele engineers their machines to a 20-year design life, guarantees spare parts availability for 15 years after a series ends, and uses standard industrial bearings, numbers 6205, 6206, and 6305, that are individually purchasable from any bearing supplier. The bearing is not entombed, it is a component. Bosch also maintains serviceable bearing designs in their premium WAW series, while Electrolux continues offering split-tub construction in select European models. That distinction is everything. The broader principle is this: look for steel transmission over plastic gear case. Look for bolt-together tub construction or individually accessible bearing housings. Look for documented parts commitments beyond the standard 1-year warranty period. These are not luxury features. They are the baseline specifications that washing machines were built to for decades, before the industry discovered that a machine designed not to be fixed is a machine guaranteed to be replaced. A washing machine is not a complicated device. It is a drum, a motor, a pump, and a handful of bearings. Engineers have understood how to build these components to last 30 years. The knowledge did not disappear. The incentive to apply it did. The sealed bearing is not a design flaw. It is a design choice. And the distinction between those two things is the entire story of what modern appliance engineering has become. The tide may be turning, however slowly. Right to repair legislation has gained momentum across multiple states. California, Minnesota, and Oregon now require manufacturers to provide repair manuals and spare parts for appliances for up to 7 years after production ends. The European Eco-Design Directive goes further, mandating 10-year parts availability. These laws recognize what repair technicians have known for decades. The same deliberate design choices that affect washing machines also extend to dryers, dishwashers, and refrigerators. When a $5 component can be made unreplaceable, the entire appliance category suffers the same fate.